Okay, sorry about that. Geometry got cut off there. Okay, so this is what we ended up with. All right. So again, make sure you read through this theorem very thoroughly. All right. Let's look at one or two more examples here. Okay. All right. One side of a triangle is 15 inches, and the area of the triangle is 90 inches squared. Find the area of a similar triangle in which the corresponding side is 9 inches. All right. So we've got two triangles here that are similar. Okay. All right. So it says that one side of a triangle is 15 inches. And the area of the triangle is 90 inches squared. Find the area of a similar triangle in which the corresponding side is 9 inches. Okay? All right. So this is what we're trying to find right here. We're trying to find the area of this triangle right here. All right. So we are going to set up a proportion. All right. So we got the area. If we take x over 90, okay, that's the proportion of the two areas. Okay, equals. Okay, so let's go back to the theorem. If I can find it. Yep. Okay, so it says that the ratio of the two areas, well, that's what we have here. We have the ratio of the two areas. One's an unknown, one is known. Okay, is equal to the square of the ratio. Okay, so the square of the ratio. Now the ratio is 9 to 15. That's the ratio of these two corresponding sides. Okay, and that can't be reduced. All right, so the square of the ratio. All right, so let's go ahead and square it. So we've got x over 90. That's the ratio of the areas. All right, now 9 times 9 is 81, and then 15 times 15 is 225. Okay, now we just have a simple proportion, right? Have a simple proportion. So remember how we do with proportions? We do our cross multiplication, so you get 225x equals, okay, what's 81 times 90. All right, 7290. All right. And then divide. So x equals, we're going to divide that by 225, and we get 32.4. So our area then is 32.4. Okay? All right. And then let's look at one more example. You'll see these are like the last three are going to be like this. Okay. So the question, let me scroll down in the lesson here. This is number 9. So number 9 says, find the ratio of the area of a triangle XBY. So we're looking for the ratio. Let me just bring it up here, okay? Find the ratio of the area. So we're trying to find the area. We're trying to find the ratio of the area of triangle XBY to the area of triangle ABC for the given measurements, okay? Now they're saying that this right here, that XY is parallel to AC, because when it is parallel, that automatically means, based on previous theorems that we've learned, that this smaller triangle is proportional to the larger triangle. It's they're similar. Okay, so we know that this side right here, BY, is the corresponding side with BC. Okay, so it's got the whole side of this smaller triangle corresponds with the whole side of the larger triangle. Do you see that? So that means we have a ratio of 2/4, which is 1/2. Okay, so do you remember? So I've got it right here. If we have the ratio of two corresponding sides, then we square that ratio to get the ratio of the areas. Okay, so we're just gonna take 1/2 squared equals 1/2 times 1/2 equals 1/4. Okay, so that means that the ratio of the two triangles, the ratio of the areas of the two triangles is 1/4. Okay. All right. So hopefully that'll give you some guidance as you work through this lesson. I'm going to go ahead and skip a few of the problems, and just do your best. Let me know if you have any questions. Okay.